All right, protocols. This is huge. It is very, very, very important. Protocols are the way that we talk with different systems on the internet. So it's very important that we use the same protocol in order to be able to talk with anything on the internet. It's kind of like saying that if everybody speaks a different language, then how are you ever going to get any work done? Well, you'd have to use translators, right? You'd have to have translation in place. If the person actually understands English, then the translator doesn't have to happen, and you know that nothing's getting missed. Well, on the internet, everybody uses the same protocol, and that is transmission control protocol, internet protocol. That's the primary one. That is basically a portion of larger chunk. IP4 and IP6 would fit right here on the IP side of that. And the TCP is a totally different thing. I think that this should be called Transmission Control Protocol, User Datagram Protocol, Internet Protocol. So I'd put Transmission Control Protocol dash User Datagram Protocol slash Internet Protocol, and you'll see why as we go through it. So the Department of Defense is actually the one that designed it, and the whole idea was, if you look at the date, is to have communications occur even though a nuclear war may have happened and you lost some communications someplace. So they really wanted something incredibly robust and dynamic, something that could find other pathways to get to its destination. And so the internet TCP/IP is not necessarily the fastest way to do something, but it's very robust and has allowed the internet to be changing constantly, and it's okay. It'll still figure it out. And that's what this is describing. So let's look at TCP/IP. To help us understand it, we actually have a couple of models. In other words, a way to frame this set of protocols to help us understand what's happening in it. And the OSI model is really, really important. The TCP/IP model is also important. This is actually a lot more of how TCP/IP functions. The OSI model is really a lot more of how we communicate. These two things are, memorize it. It'll save you time because you're going to have to memorize it in networking. It's really a way for us to talk back and forth and know what each other means. It's also a way to define where these protocols, at what level they're running in the network system. Because again, it's back to that layers concept. All right, so let's take a look at really what this breaks down into. There's tons of information on this on the internet. There's a lot of network information that is not on the internet because it costs money to learn those things. But the basics of networking are all over the place and explained all over the place. And I think this is a really good graphic here. As a matter of fact, a little later, I think I'm going to blow this up and copy it because it's fantastic. All right, so TCP/IP model, this is what we're dealing with. This is what they're showing us. And there's this massive application layer in this model. And then there's a transport layer, a network layer, and then the network interface. And these are the protocols that are running there. I think it's easier to explain when you see something like this because you'll recognize a few things. Like you'll say, oh, HTTP. Wait, there's TCP, right? You'll pick up on a few things. In networking, not joking, we go through every single one of these protocols and more. And so again, learn what you can now. It will really help you out for later. So the network interface is, how am I connecting with the network? How am I going to connect with that? And that has a lot to do with the physical device that's on there, right? The network card, and how is it signaling? In this case, Ethernet, that's usually what we use. So that's the network interface. It's the protocols that define keeping a physical connection between it and whoever it's talking to on the network. The network layer, it deals with actually what protocols am I using to get beyond the local network? How am I getting beyond that? And this is where IP fits in. So IP, having those numbers on your computer, that's at the network layer. That's solving the problem of how do I get out of the LAN and onto the WAN or onto the internet in this case. The transport layer is how am I going to take that data that now that I'm on the network, how am I going to take it back and forth? So TCP, Transmission Control Protocol, the C, control, means I'll control it. I'll make sure that it's happening. I'll take a look at things every so many seconds and make sure everything is right. UDP is the other one that exists there, and that's User Datagram Protocol. And that basically is like, okay, I established a connection with you. I'm going to just go ahead and send the data. I'm not going to do as much error checking. And so things like YouTube and anything that requires streaming, like you watching this video, is going to be sent UDP. And anything that doesn't demand that, but demands a higher level of, I know what's happening, that's TCP. And then finally, the application layer. Now, we would think applications, okay, so that's Word and that's Chrome browser, and that, no, that's not what they mean. They mean the applications that allow whatever's above that in the OS to actually work. DHCP, like where do I get my numbering for the networking at all? Network time protocol, how am I going to get my time? HTTP, this web page here is HTTP, right? How am I getting that information? And by splitting this out, you are really getting to the point where you can talk to somebody about it. Like, I think the problem is actually at the application layer. See, if I say that, I don't have to explain this stuff. I don't have to say, oh, what I'm meaning is, let me go through all of it. Or I believe the problem is at the network layer. Oh, you mean it's in IP or ARP, something within that? That's what you're referring to. And so this model is important for development, like for programmers and such, but it's important for people that fix networks and deal with networks, because if they understand those layers, they can directly talk to somebody about it, and they both understand what's happening. And the OSI model breaks it down even further. I don't believe they get into that. Nope, they don't. And so we're not going to get into the OSI model here either, but it breaks it down even further. And the OSI model is usually how people talk, but the TCP/IP model is a little more easier to understand. It's how TCP/IP actually functions. All right, so moving on to some other things. DNS, or domain name system, that is what matches up our IP addresses to the URLs. Again, we as people, no problem understanding www.testout.com. No problem understanding that. Actually memorizing what IP testout.com goes to, that's, no. I remember the days when, and I can still think about it now and think of my friends' phone numbers, because we had to call on the phone all the time. Now we don't. Now we just say, oh yeah, shoot me a text. Here's my phone number. I barely remember it. There you go. Okay, send me a text back. Now I have yours. We don't even know phone numbers, right? But we know the person's name. We allow the phone to do the translation for us. If the name's there, I hit it, but it doesn't use the name to make the phone call. It uses the phone number to make the phone call. DNS is exactly the same thing. For all these, Google.coms and Bing.coms and everything.coms, the DNS servers are matching those names to numbers. It's a big, massive directory that does that. Of course, HTTP, that's what we use to actually transfer pages like this. And HTTPS, which is the same thing, except it's using a secure socket layer to encrypt the data. Like this is encrypted. If I click up here, you'll see the little lock. Right? That little lock means that what it's doing is HTTPS / and then this address. And that's how it's getting there. And then our email protocols. So SMTP by far is the biggest email protocol that we use. It is used to send mail between servers. SMTP is used by all email systems that use the internet, right? So SMTP is like the core email service used to send mail. When you send a message, SMTP routes it through the internet. So it's hitting these SMTP servers basically that understand SMTP in relaying that. I don't know why POP3 is stuck in the middle. It's another one of the annoyances. It should be way down at the bottom. So let's talk about IMAP. IMAP is what we use, is a much more common receiving protocol for getting your mail. With IMAP, messages stay saved on the remote mail server. This way, people can access their mail from multiple devices, such as home computers, work laptops, and smartphones. IMAP is what we use on our devices. So SMTP is used when you send a mail out of your phone. IMAP is what's used to send mail to you on your phone. POP3 is an old protocol that can still be used if you want it to, but its problem is it's not as user-friendly. It grabs messages from a remote server, downloads them to the local client, and then deletes them from the server. What this means is that if you used POP3 and you had a computer and you had your phone, then if you're using POP3 and your phone went out and got that mail, it brings it down to the phone, it deletes it from your server, and then when your PC goes to get that mail, it's not there and doesn't get it. We like things synchronized. That's what we like. We like our mail on our PC to look like our mail on our phone. And so IMAP allows that to happen where POP3 does not. POP3 is only really useful to you if you're going to use it, talk to one server at a time and say, I'm getting POP3 and that server gives me my email and now it's deleted from there. It's not really useful. Not used as much. It's not used hardly at all. And of course, that means that when you're configuring email accounts, you actually have to know, you actually have to know the IMAP location. Like for instance, if I'm using IMAP, not joking, Gmail will have an imap.gmail.com server set up with the appropriate protocols and ports all ready to go. They'll have a POP3 server set up that way. They'll have an SMTP server set up that way. Of course, ours are usually all automatically set up thanks to a little program that most people aren't even aware of that gets licensed out from Microsoft that negotiates all that stuff and goes, boom, I'm done. And it's ready to go. You just say, I'm using Gmail. And then it goes, oh, okay, so it's probably this, boom, 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 sets it all up. But sometimes it doesn't work that slick. And knowing that behind the scenes, you are using SMTP to receive and IMAP to send will then hopefully logically flow into your brain, knowing that if I have to set this up manually, I need instructions for what IMAP server they're going to and what SMTP server it's coming from, right? And you can imagine what email filtering is. Let's see. Also, I should mention DNS. This is all about DNS, so take a look at it, read it. DNS is a hierarchical system, meaning that there are many DNS servers are used to locate the desired IP address. Since no one DNS server holds all the possibilities. So a DNS is a distributed hierarchical database system that's all across the internet. And when you type in, I need this, you're going to talk to a local DNS, and that DNS is going to go, I'm going to talk to another DNS. I'll get that information and bring it back to you. And so it's a very, very detailed, complicated system that in networking we discuss a lot more. At this point, what you need to know is we're dealing with this to this. Now, when you type in testout.com, it does not make a request based on that. It goes and finds the number and then makes the request. All right, so got questions or you want to know a lot more, I've got tons of links I can send you. I can send you another video that I use in networking or make another video that I use in networking. I need to refresh that one. All about DNS or any of these topics that we have here.